Assalamu alaikum, dear students. Welcome to your mathematics online classes. Today in this class, we will be discussing the next chapter, that is continuity and differentiability. It's from class 12th NCERT textbook. Dear students, you are well aware about the concept of limit from class 11th. And when the limit exists for a given function, I would like to recall the concept of the limit and when that exists for a function. From your class 11th, I've highlighted it here, that if x tends to a, f of x tends to L, then we say that L is the limit of the function f of x, which is symbolically written as like this. In the green color, I have highlighted it. Limiting value x tends to a, f of x is equal to L. So this L is any finite number. This L is any number. We say that it exists and limit exists. So in the class 12th, we are now going to discuss the continuity of a function. So for the continuity of a function, what we have to do, we have to once again to go to the concept of the limit. Suppose we have a function. You see here the definition one. It's on page number 151 of your textbook. So it is, suppose we have a function, a real function on the subset of real numbers, and let C be any point in the domain of f, that's domain of definition of the function, given function f, then f is said to be continuous at C if limiting value of f of x at x is equal to C that equals f of C. So here some points are to be discussed and they are very important to note. That is what this left hand side mean. This means the limiting value of a function f of x, and right hand side means the value of the function f at given point C. If these two agree, we say that the given function is continuous at this point C. It's continuous at point C. So in class 11th, you have noticed that this f of C was actually L. And we used to say there that the limit exists whenever this limit tends to some quantity L, okay? But here in class 12, this L is replaced by f of C. So there's a difference, that L can be any quantity that may or may not be the value of the function f of C. So whatever that is, limit exists. But if it is f of C, if it's value of the function at this given point C, we say that uh, the function is continuous. So simply, I would like to highlight the definition like this. If the limiting value of the function at given point C equals the value of the function at that point, we say that the function is continuous. Okay. So for the sake of simplicity, I would like to highlight it once again here. So it is in the italic. This is a function is continuous at x is equal to C. If the function is defined at x is equal to C, and if the value of the function at x is equal to C equals the limit of the function at x is equal to C. And I would like to highlight once again here that the function, if it is not continuous at x is equal to C, then we say that it is a discontinuous function at the given point C. And C is called the point of discontinuity. Okay. So now we have some functions here and we will check their continuity. So the very simple example, it's example number one. We will check the continuity of the function f of x is equal to 2x plus 1 at point x is equal to 1. So let's check it here. We have a function f of x where we find the limiting value at x is equal to C. That is C is equal to 1 here. Limiting value x tends to 1, f of x is equal to limiting value x tends to 1. And instead of f of x, we have 2x plus 3. Okay, so we will use the limiting value x tending to 1 here. So it's 2 into 1 plus 3, that's equal to 5. So this is the limiting value. Okay, limiting value is equal to 5. Now we will check what is the value of the function at x is equal to 1. So value of the function at x is equal to 1 means we have to replace x by 1. So it's 2 into 1 plus 3, that's 5. So it's 5, and limiting value is also equal to 5. So these both values agree. Okay, so we say the function is continuous at x is equal to 1. Okay, similarly we have example number second. On the same lines we can solve it. And example number three, that's modulus function. Once again, it's continuous function. Although it's a setup function, it is divided into two steps. One is for the negative side and positive side. And at x is equal to 0, there is wedge shape. At that point, we have to check it uh, carefully, but at that point you see that x is equal to 0, it's also equal to 0 functional value and limiting value from either of the sides, either from the left or from the right, it's equal to 0. So we say it's a continuous function. Similarly, here is next step function, that's example number 4. F of x is equal to x cubed plus 3, and f of x is equal to 1. This is for x non-zero, and this is for x is equal to 0. We will check whether this function is continuous at x is equal to 0 or not. For that, what we have to do, we have to find the limiting value and we have to find the functional value. For the functional value, we have at x is equal to 0, this is equal to 1. So this is equal to 1. Okay, so this is the functional value. Okay, and the limiting value can be calculated from the above branch of this function. So it is the function is defined like in the above, and we will now find its limiting value. Limiting value extending to 0. F of x is equal to limiting value extending to 0. That's x cubed plus 3. It is 0 cubed plus 3. That's equal to 3. You see that limiting value is equal to 3 here. Limiting value is equal to 3. But the functional value that we have seen here, functional value is equal to 1. That's not equal to 3. That's not equal to 3. So functional value does not agree with limiting value. So this function is not continuous at x is equal to 0. Okay. So this way we can check the functions for the continuity. Note that this is a constant function. F of x is equal to k, or k is any non-zero, k is any scalar. So this constant function is a continuous function for all values of its domain of definition. Okay. Next definition I would like to highlight here is that if a function is continuous at every point of the domain, then it is continuous in the domain of f. Or in other words, we can say a real function f is said to be continuous if it is continuous at every point in the domain of f. Okay. For example, we have an open interval, that's the domain of definition of the given function. Okay. If it is the function is continuous at every point between a and b, including a and b, then we say that the function is continuous in the whole interval. And one important point is that right hand limit for a makes sense, but left hand limit for a at a does not make a sense, so we don't calculate this. Left hand limit for b makes a sense, but right hand limit for b at b does not make a sense, so we don't calculate them. So their continuity is only one way checked. Okay. So similarly here we can see all these functions, and in the exercise we also have the functions of the same nature. You can see here, see it is f of x is equal to 5x minus 3. Limiting value and functional value can be calculated at x is equal to 0, minus 3 and 5. Okay, so we will see that this is actually a polynomial function, and the limiting value is agrees with the uh, limiting value agrees with the functional value. So this function is continuous at all these 3 points. On the same lines, this function is also continuous at x is equal to 3. And then after we have to check these functions, these are also same. Okay, you try your best up to what you can, up to what question you can solve these examples. Will be once again in the next lecture solving the exercises related to continuity of the function from this exercise 5.1. Up to that time, Allah Hafiz. And with this point, that if you have any query regarding any question or concept, you are free to ask it in the group or in the comment section of the this video. Thank you for joining the class. Fi amanillah.